So do I have an hour or how long?
We've got an hour, and if there's time at the end, we normally have a lot of various questions about various things. So so I've started the recording, I believe. Yes, and over to you, Gary.
All right, let me start a watch so I can see how much time I'm burning. Okay, yeah, so I would like to tell you about a PSA level fuzzing tool that I have worked on for the past, several months anyway. Just to clarify, I've previously been on the TFM team, which, as you may know, TFM is arguably at least more, it is arguably not a lot more than PSA when it comes to security stuff. PSA, of course, is kind of coming, so to speak, for TFA, but it's not there yet, but it's getting there. And this, therefore, is the tool. The goal of the tool is to try to get some, exercise the PSA implementation as much as possible by randomized means, which is, I guess, what I probably ought to start by talking about that. Because there was one of the certification labs, the one in China in particular, was thinking about coming up with a fuzzing tool of their own, and we decided that it would be better to have an open sourced, being an open source project. We think it'd be better to have an open sourced tool for that purpose, and I was already working on one, so delighted, I figured, to get it out there. So that's what we finally put into the TFM release in, I think it was in March, the 1.0 release. And this particular tool, it's kind of in its early stages. It's just basically just been me working out for a few months, but it's starting to become a useful tool. Can everybody hear me okay? I think there's somebody, I think somebody is unmuted. All right, I think several people might be, okay. Can everybody hear me okay? Just checking to make sure everybody can hear me okay.
Yes.
Yes, I can hear you.
Yes. All right, okay, okay, cool. Okay, thank you. Just wanted to make sure. Okay, I'll pop the tab here on a beer. No, Coke. Right. So it's coming along. It's starting to become a useful tool, but it's worth pointing out that since that it is not targeted strictly for TFM, though, because there's a, let's see if I can use my pointer. Yeah, it's initially targeted with TFM, but there's basically just a single file of boilerplate code that is syntax specific TFM or syntax specific, and all you do is really make if there do in fact turn out to be any really significant differences syntactically between TFM and TFA, all you have to do is change that one file and point an environment variable at it, and you've got the TFA version. But I can talk about that later if anybody's interested. But the point being, we should be able to retarget it to TFA with no big issues. Now, this was originally intended as a target-bound TFM tool, meaning that it would be a fuzzer running on the TFM target itself. That was the original intention. And the goals that it had in mind were not only to do random testing, and okay, I'll get into that in a moment, but not only to do random testing, but also to look for security issues that might come up, and also just simply to make it easy to write a whole lot of tests really quickly. So those were the original goals. Now, Currently, though, as I mentioned, it was originally intended to be running entirely on the target. I ended up, what we have now is strictly the opposite. It's a workstation-based code generator, and nothing about it is running on the target other than the tests that it generates, which are compiled like any other code and then run on the target as compiled code. The reason for that change of thinking, well, there are advantages to either approach. You could either have a workstation-based code generator that has advantages, or you could be a target resident interpreter in essence, and randomizer. The main reason why I postponed it at a minimum, gave up on in the extreme, take on putting anything in the target is because TFM targets tend to be extremely limited in terms of RAM and compute power. So if you put any smarts on the target, you're probably going to run out of smarts and space in a TFM target. TFA targets arguably might have more room, in which case we could perhaps have more cleverness going on the target itself. But the long-term goal, generally speaking, is to come up with a more cooperative, I guess you could say, management of the test, the proceedings of the test, partly managed on the target and partly generated on the host. Currently, though, this is strictly a host code generator tool as it currently stands. It's conceptually possible that you could, run the this TFM, or well, trust this PSA level fuzzer conceptually could be modified so that it runs itself entirely on the target if your target has enough space. And instead of generating code for it, just simply directly executing the PSA calls. That is conceptually a possibility that of how one could do this entirely on the target. And the advantage, of course, being that you could just run it continuously on the target. And anytime anything doesn't look good, you can report that. It's also conceptually easy as a first step toward a more cooperative arrangement between the target and the generated test. It's conceptually possible to provide a plug-in mechanism whereby the partners can plug in code that models other things that they are concerned might confuse the PSA implementation. And it's conceptually easy to have the plugins run in addition to the code that's the generated code. So that's sort of like a good possible first step. And then as time goes by, we could have more randomization done on the target and so forth. But for now, it's just strictly a workstation-based code generator tool. There's so I refer to this as I refer to the input to the tool as a test template. That's sort of borrowing after, it's coming from my early heritage at ARM, working on the Raven tool, which it's a random testing tool for CPU, pipeline level stuff. But they called the inputs to that tool, they called a template, a test template. I created, therefore, a language for what I call a test template in this case. But this language is, I don't know, it's kind of an exaggeration to call it a language. It's very simple, as you will see in a moment. The important point of this is its directed randomness. Complete randomness is arguably of dubious value, because what almost always happens if you have just totally random parameters to your calls, what almost always happens is you end up just getting random failures, a whole lot of negative testing, so to speak. meaning that you're generating a whole lot of bogus results, which is of course valuable to test as well, but hopefully you want to test more. Since most code will behave properly up to a point, hopefully you'll be testing more plausible, at least seemingly plausible cases. But you definitely do want to test negative testing. You want to make sure that known wrong things are handled correctly. And there are provisions for that, as you will see in this tool as well. But it doesn't produce just purely random stuff. The idea is to use this test templating language to come up with an environment, a world in essence, in which you then randomize the activity, the PSA level activity, to within that environment. That's the basic concept behind it. So with this test templating language, you describe an environment and then say, okay, do this kind of randomization, random PSA call generation within that environment. Yes, right. One very reasonable question that came to mind is, why come up with a high-level abstraction language like I'm describing here for specifying the nature of a test, as opposed to just providing something like MicroPython that you could download into the target and just tell it to do whatever you want. And that's potentially a way in which we could expand, again, as I mentioned earlier, want to make, in the long run, we'd like to make a more cooperative test management type of framework, and that might be a way of doing that. But there are downsides to providing just a general purpose language. The most obvious downside is that although you, here's my pointer, although you can do anything you'd ever want to do with a general purpose language, the problem is that you must do it all yourself, whereas an abstraction gives you a way of describing a test, and it does the thinking for you, so to speak. Here's the problem with providing a general purpose language. If you catch my drift there, again, the downside with just providing a general purpose language is that it's great that you can do everything, but the problem is you have to do all the work. You're forcing all of the cleverness on the user. Again, one of the goals here is to simply be able to generate a whole lot of tests really easily and do that based upon random stimulus. You'll see, I'll go ahead and describe, here's the quick picture of what this, if you can call it a language, that I came up with for the test templates. And basically it's just a series of keywords. Set, remove, currently this is not the complete language, but it's the most important pieces of it. Set, remove, or read. So set is to either create or redesignate data for some asset. Read means to look at that asset, see what's in there, and perhaps you can do things with what you see in there. And then remove is to remove that asset. What are the natures of the assets? Well, you do it by PSA asset type. So secure storage, key, or a policy. Now, I should point out that we don't currently there's only support for secure storage and crypto. And currently crypto is limited strictly to creating, reading assets, reading assets, and removing them. I'll also mention that the current crypto spec doesn't call them policies anymore, but that's what they call attributes, attribute structs. I needed a simple word for it in here, so I retained the old terminology of policy. But anyway, then you specify, so you could say like set key name, and then you choose a name, whatever you like, and then you say what you want the data to be, or you could say star, which means to just come up with your own random data, tell the tool to come up with its own random data. And then optionally you can tell it what you want what you expect the results of that call to be in terms of pass or fail or some particular error code. And then there are also, as I mentioned, another goal was to try to have some security testing, in particular for data bleeding between assets. Initially, that was the main target for security testing. I'll talk about that earlier, but there is currently very, very limited support for that, and it is of the nature of when you read a particular asset, you can tell it to create a simplistic hash of that, and then you can tell it to compare a whole bunch of assets hashes to make sure that none of them are ever the same. So that's a very simplistic data leak check thing. Currently, that security checking provisions are very limited, but that's a goal. Yeah, important thing to note, I think, and maybe this is, okay, so I'm saying fuzzing requires modeling. Or maybe some might argue that fuzzing, in the usual sense of the word at least, is not exactly the same as random testing, where, and I guess it might be fair to say that this is somewhere between random testing and fuzzing, in the sense, and I don't know, it's kind of debatable as to what the difference is, whether they're the same or different, but a lot of times fuzzing is more of the nature of generate totally random inputs to the thing and make sure that it doesn't ever become a non-responsive, doesn't crash. A lot of fuzz testing seems to be of that nature. This is really more of the nature of providing directed random stimulus and trying to be able to predict what the expected results are. So as I like to say, you've only done half the job if you're just generating random input, random PSA calls. You've really only done half the job, because if you don't model what you expect the results to be, then you don't know whether it behaved correctly or not. So part of what TF Fuzz tool here is designed to do is to predict expected results and check them appropriately. Yeah, let's see. All right, so I'm going to do a demo of the tool as it currently stands. And again, it's still in a somewhat early stage, but it's getting to where it's starting to become useful. Yeah, so I would want to clarify that initially the demo was really more of the nature of showing what the test template language is like, and also just simply to show that you can get a lot of code. It'll produce a whole lot of code for you with just from a very simple input. So the first few examples are just sort of party tricks, so to speak, just to show that very little input will produce a whole lot of output for you. It'll do a whole lot of testing for you with just a little bit of input. And it figures out all the nitty-gritty syntax nonsense for you. Oh, by the way, there is, for those inside ARM, there's a Confluent site that talks about TF Fuzz. I can, yeah. Okay, anyway, right, get on with it, dude. Okay, I'll switch over to, yeah, okay, so let me show you what I have here. This is just a directory that is part of the release. And what I'm doing here is, this is just a shell window, nothing tricky. And I just have this little script, if you can call it that, that I call R for run. And if I say R1, for instance, it'll run test case 1, which looks like this. And as you can see, first thing this R script that I'm running does is it just spits out the input. This is the input to the test template as it's called. That's the entire input to the tool for this particular test. This then is the verbose output from the tool that just tells you a little bit more about what it's thinking as it generates the test. And then if we switch over to here, this is the generated code. Okay, so this is a pretty nothing test. It doesn't really do anything particularly surprising. All it's doing is describe the purpose of the test, which, as you can see, shows up in the log, gets put into the test log, and also in this comment at the top of the code. This is the generated code again, and yeah, so basically it does exactly as you imagine. This says to create a secure storage asset. UIDs, unique IDs, are how you specify a secure storage asset. It's just a number. In this case, I specified the number, which again, it's not a very interesting test, but I'm just trying to show the nature of the language here. And I specified the data that I want the asset to contain, which is a very simple test, nothing else. And I told it that I expect it to pass. And what does that produce? Well, it produces this code. Just a little bit of preliminary stuff. It declares variables that it needs, including this is the data. There's a variable where it stores the data that it's going to, stuff into the asset, and that's the length of it is 16, and yeah, and it basically just issues that call to create the asset. And since I told it to expect a pass, it says if the result is not a pass, then say, hey, expect it to pass. And then when it's done, it cleans up after itself to make sure you don't leave junk sitting around in the flash of the target, and finishes the test. So that's a pretty boring case, but just to illustrate something, let me see if I remember yeah, okay, I can switch over here. So here's another one, just to illustrate, you got 4 total lines here, and yeah, so those 4 lines generated quite a lot of code for you here, just to illustrate that the test template specification language can do a lot of work for you. And we can go over this one later, but basically it's creating assets, then generating hashes of the data in those assets and comparing them to make sure that nothing bled, no data bled between those assets. But let's go on with some more. What I'm going to do is I'm going to do a progression of successively more complex test templates. But let's see, like if I run test template 2, the only thing I'm doing differently here is I'm giving it a human name rather than UID 104 or whatever. I'm just giving it a human name. In particular, I'm calling it forecast. So create an SST asset with a name of forecast and data. Yeah. In this case, I'm doing something interesting. I'm saying expect nothing. Well, what does that do? So again, I'm giving it a name, so you can see that it uses that name in the variables that it creates. And it picked a random UID for that. And because I didn't specify UID, it picked a random UID. When I said expect nothing here, what does that do? Well, that just means that it will not do any tests for check for its success or not. This is not something that you would expect. Nothing is probably not something that you'd want to do very often, but it's an option if you want it. Let me see, let's get some more interesting cases here. Yeah, let me look at what we have here. Trying to remember what all these demos I have here are. Yeah, Okay, here's, in this case, notice two big differences from the previous ones. Oops. So in this case, notice that I'm not telling it what to expect anymore, which means that the tool has to figure out what to expect of this particular SST call. So it has to figure out whether it should pass or fail. I'm describing the name, I'm specifying the name of the asset, but I'm telling it also to generate random data for that asset with the star here. So what does it do? It creates an asset called gibberish, and it gives it data of yay, boo, mop, talk, torazig, yeah. By the way, I intentionally, I could have just done random characters in concept, but I decided to produce gibberish that is vaguely pronounceable for I think a good reason. The reason is that they are more recognizable, if you see what I'm saying. So if you're trying to follow a particular data value as it moves around between assets, it's easier to say, oh yeah, that's the Yebu mop one. Yeah, okay, how'd it get over there? That kind of thing. But if you run this again, you can see that it created different data for that asset. C on oimek u bit, yeah, right. Or so if you run again, you get a different, yeah. Let's start getting more interesting here. Okay, in this case, I'm doing a random name and I'm letting it pick the name of the assets, and it calls the asset oihebsu and generates random data for it as well. Also figures out that, hey, that is a new asset. I should have no problems creating a new asset. So it says, yes, that should be successful, and if it isn't successful, it'll fail. Again, it's still always cleaning up after itself. But yeah, let's start getting more interesting. What do we have under here? Okay. Let's should I move a little more quickly on this? Yeah, so okay, here's a case where we're not creating an asset, but we're instead just reading a non-existent asset, right? As you can see, I just specified a purpose for the test, and then I told it to read this asset that we never even created. Okay, so I would hope that would fail. We certainly hope that it will. I didn't tell it what to expect, but hopefully the tool will. I hope the tool will correctly infer that that's not going to work. Reading an asset that doesn't exist will not work. And just to check, yeah, it says that it checks. So it checks to make sure that the status of this get of a secure source set, it checks to make sure that it returns the error does not exist, and if it doesn't, it generates fail for that. And yeah, so let me show you a little bit more about this. Read, when you tell it to read any particular asset, it does a little bit more work here. You see that it creates expected data for that. I said, check this doesn't work, this won't work. Well, it's obviously not going to work because the asset doesn't even exist. It also creates an actual data buffer in which to put the data that it reads from the asset. And I then fill it with random junk so that it will, so that you can tell if it never even read anything at all, if it still looks like the same junk. But yeah, that then is the length that it plugs into. Yeah, anyway, actually that's not the length that plugs in, but in any case. But anyway, yeah, so this is a case, as you can see, where it correctly inferred that it should not succeed. That particular case should not succeed. Yeah, let me see what else we have going here. Okay, now we're starting to get a little more interesting. Let's see, let's try this one out. This is another case where things should not work. In this case, I created an asset called George with random data, and then told it to remove an asset called Ringo. And that's not going to work, I hope. So here it's creating the asset with name George and this initial, again, random data. And then I tell it to remove some random asset that doesn't exist. Again, it only has, so far has only created this asset. And we expect it to show it does not exist. So, and of course, then afterward, it removes the asset that does exist, just cleaning up after itself. Let me see, I think I may have missed some more interesting cases here. Just a moment, let me find, yeah, okay. Let's try, yeah, okay. This is, again, just in terms of generating results, a lot of results with a small amount of input. It says to create 5 total assets, secure storage assets. They call him George, John, Paul, George, and Ringo, so 5 total. And it, as you can see, creates John with these variables, Paul with these, George with these, and with these, Ringo with these. And as you can see, it creates all of them, checking the result, and then doesn't do anything with them, deletes them all. Okay, so that's really just more along the lines of showing that you can create a lot of testing throughput with just a single active line there. Right, let's start getting more interesting here. Okay, now here's a, we're starting to get a little more interesting here. So in this case, it's going to create a total of 1, 2, 3, 4, 5 total assets. Or sorry, did I count right? Yeah, President, George, Herbert, Walker, and Bush. 5. Can I count? Yes, 5 total assets. And it's then going to just remove at random some active assets, some existing assets. So the idea is you'll create 5 assets and then pick one and remove, pick one at random and remove it. So let's see what that did. With these, yeah, variables, it created President here, George here, Herbert here, Walker, and Bush here with these UIDs. Then it deletes, which one? It deletes George and this particular run. And then as you can see, it cleans up. It does not try to redelete George because it's already deleted. It knows which ones it's deleted and doesn't do them. If you run it again, let's see who it decided to delete this time. It deleted 8960, which, oh, it's George again this time. Hopefully it's not stuck in a rut here. This time it's removed Bush and so forth. Each time you run it, it'll remove at random a different one. Yeah. Let me show you some more interesting, more involved. So with this particular one, I'll just go ahead and run it. That's 18. So this is some more interesting randomization here. It's using this directive here called shuffle. And what that does is it will, after doing this creation, after it creates the assets Shiva, Brahma, Vishnu, and Ganapati, it then does all of these, it generates all of these calls, but in some randomized order. So first time it may do them in one order, and the next time it may do them in a different order. In this particular case, it did them 30142. So it did 30142 in that order. So you can, that's why this verbose outfit is sometimes useful. And let's see how that came out. Here you can see it's creating all of those and all these assets. And as you can see, it did create data for resetting, in this case, Brahma, Shiva, Vishnu. And let's see where it did that. So at first, as you can see, it creates Shiva, then Brahma, then Vishnu, then Ganapati. Then which one did it decide to do? It decided to reset, decided to reset Vishnu to I am the sustainer here. And then it removed who? 67, it decided to remove Shiva, which was this command doing the remove of a random asset, and apparently it chose Shiva in this particular case. And then it reset the data for Brahma here to let's see, Brahma is the creator, right? And says I am the creator, yeah, right. Anyway, so it reset the data for Brahma. Anyway, point being that if you run this again, you're going to get a different order, 03142, and you'll get a different code for it. Notice that it has differing set data for each of them. Here, because we said data star, meaning you invent Hey Tool, Hey PSA Fuzz, you generate data for them. And again, each time you do it, you'll get these PSA calls in a different order. Run it again, and yep, you got 3-1. Yeah, you see the concept. There's also another kind of similar randomization option called, let me find it. Yeah, okay. Here's another randomization option that you can use. And this is 2 to 5 of these. So after it creates secure storage assets, Neil, Buzz, and Mike, then it picks a number between 2 and 5, and then does that many random choices of these 4. So let's see what it did this time. In this case, the number between 2 and 5 it chose was 2, apparently, and it decided at random to do calls 3 and then 2, which are 3 here, remove Neil, and 2 to create Chris Craft. Chris and Craft, I should say. So, so let's see what it did here. It's creating Neil, Buzz, and Mike. And then 3 was, let's see, right, 3, yeah. 3 is to remove Neil. So it removes Neil, which hopefully is the correct, yeah, UID for that. And then it creates Chris and Craft and cleans up after itself. If you run it again, you see that it decided to do 4 calls at random this time, and they were 1, 3, 0, and then 1. So 1, 3, 0, and then 1 again. And that ended up looking like this. Okay, so I'll just, I don't want to, yeah, I got a little bit more time. So far I've only been talking about secure storage. Let me show you a little bit about what it can do with respect to crypto. Currently, that's a little new. Hopefully no surprises will come up, but we'll see. Yeah, so let's see. Oh, here's just real quickly, here's another one that generates a whole lot of very random code As you can see, it's got a whole lot of randomization going on upon a lot of assets, and that ends up producing quite a lot of code for you with a lot of random possibilities in there. So this can do some pretty significant randomization. But anyway, let me talk a little bit about crypto support, which again is new, but it's coming along. And as I think I mentioned earlier, it's currently limited to just simply the same types of things that I just described for secure storage, only creating, resetting data, removing and reading, looking at keys. Currently, it's limited to that, and to specify a key, you need to have a policy asset as well. Now, I should point out that there is really not, strictly speaking, there's no policy asset anymore in the crypto API, but you have to specify a set of qualities of the key, and you do that in what was previously called a policy. They don't call it a policy in the crypto spec currently, but they just call them attributes, structure. But anyway, I need to have a simple keyword that I could use, so I retained the policy keyword, the policy terminology there in this tool, just so that I can have a simple name for it. And also I wanted to use attributes to specify what attributes you want. So an attribute, using attribute here for that would be a little harder to, make the language harder to understand, I thought. But anyway, here's just a simplistic thing. We're creating a policy, which is just an attribute structure as far as the crypto PSA crypto call sees it. And what you're doing, you're creating a policy, and it's called nothing much. And what are the attributes that you're going to use once you create this? The point is that you use this policy as attributes of keys that you create under it, using these attributes. And what you're saying is, I want that key to be exportable, the data of the key, make it possible to send it out to the world, so to speak. So for instance, if it's a public key, for example, you want to be able to send out the public key. So you're saying, I want any keys created by this policy to be exportable, the data of the key to be exportable. And I also want it to be volatile, meaning that, basically meaning that it's in RAM as opposed to stuffed away in Flash. Essentially, that's what that means. It's, as you will see, it's actually creating quite a lot of calls here. And the reason, I'll show, the reason is that you have to specify all relevant attributes of that policy. Now, what it's doing when it creates that policy is it's randomizing everything, basically. So all of the possible attributes is creating some random value for all of them. And then, since we specified that it must be exportable and volatile, it is setting the export and volatile attributes while leaving the others random. So as a result, it has calls to set it as usable for decryption, and I told it that it needs to be exportable, so that's coming straight from here where I told it to be exportable here. But decryption, usable for decryption, that was randomly chosen. Usable for encryption, that was also randomly chosen. Copyable, meaning that you can copy a key defined by this policy. And it had to create calls to first to simply define that attributes struct. Then it had to zero out, in essence, the attributes, and then add on each of these attributes one by one. And one thing that's important to note is that it does those in a random order. So even though we're rerunning the same test, it will do them in a different order each time, as well as having different randomized attributes in the first place. So although these still have volatile and exportable, the other attributes this particular time, I think that, yeah, it looks like it only had one other attribute that it randomized on in this particular case. So each time it has random attributes and then applies whatever attributes you specify specifically to it. And everything else stays random. Let's see, what else? Yeah, I still got some time, but not a lot. I'll try to get more interesting. Let's see. Okay, right. In this case, the name of the policy is, it just tells the tool to choose that. And again, in this case, it's saying what kind of a key it is, a type. It's an RSA public key, and the algorithm to use for the usage of the key is RSA PSS. So the code generated here. Oh, one thing I should point out, by the way, currently it's not checking the results of running these PSA calls for keys for crypto related purposes. It's currently not checking the results. That's well, something I'd like to add. But currently, normally I intend to add things like this where it would check to make sure that the results are the, so it'd have something like that after that to check the results. Currently, it's not doing that, but that's something I'd like to add is that when I or somebody else gets a chance, because it looks like I'm not going to be able to work on this much more. But anyway, so yeah, it's again creating these. A lot of these are random chosen. Again, the only thing that this required is that it must be a type, that type, and that algorithm. So as you can see, it sets other randomized chosen flags. These are all random chosen because I didn't specify any flags, any usage flags. But here it's setting the lifetime persistent. Actually, that was random chosen. It's saying that it's an RSA public key algorithm. Where is that? Here we go. Setting the algorithm up there, up here. These can be done in any order, and it makes a point to randomize that order. So here it's setting the algorithm here, down here. And what's interesting, let me see if I can find which one does that. I have what I call a barrier mechanism, kind of sort of analogous with barriers in the memory barrier-ish sense of the word, but let me explain what I mean by that. Okay, in this case, it's creating 3 policies, a policy, another policy, and yet another. All of them are that algorithm, SHA-256. The length of the key, I just picked a number, 523, just whatever. Notice I just called it an attribute of 523. That means length of 523, and making it not exportable. So let's see what code that generated. Oh, I didn't run it. What was that one? Yeah. R23, run 23. So in this case, the code it generated is here. And again, I'm not yet checking the results of all these, the correct, the pass fail of these. Again, I haven't added that yet. But you can see with this verbose output thing, look at the policy names here. You'll see that it intermingles calls for a policy with calls for another policy, with calls for yet another policy. So yet another and another policy, that it intermingles them around. Each time you run them, it will run them in a different order. But it will always make sure that, for example, you don't do anything related to another policy, which is the second of the 3. As you can see, another policy is the second of the 3 created. It doesn't do anything related to another policy until it has done this initialize that it has to be done first. and it never does anything for any others until it has done the initialize. So in this case, yet another, which is the second one, there had better not be, if I did my work right, there will not be any yet another calls done before that, and there do not, and indeed there do not appear to be, because I created this barrier, as I call it, mechanism to make sure that I don't randomize, I don't move earlier in time any calls that are dependent upon that initialized policy call having been done. So as you can see, it's
so Gary, we've only got about 6 minutes left. I wanted to sort of give some time for any questions that people had.
Yeah, and so I think actually that's pretty close to the end. The only thing I wanted to add was it does let you create keys on top of that course, as you would expect, and remove keys, and yeah. So that's based upon the policy. So you can specify, and you can copy keys as well based upon that. Yeah, I think that's really basically all that I intended to show. All right, so 6 minutes, go for it. Let's hear some questions. And if you don't start asking questions, I'll keep babbling. So you better get your questions going quick before I keep babbling.
So I'm not hearing any, but and I've got one. So when you put these test cases together and you get the wording wrong and everything, you know, how forgiving is it to debug how you write your test cases?
Yeah. So this is all parsed by a pretty straightforward. It's a Lexiac grammar. So let me screw it up. All right. So this so this I think would fail. Let me just try that real quickly. And I'm sorry, am I running the right one? 20 or 32. So it says on template line 3 here, it says that, so Lex is kind of, or excuse me, GAC is kind of, in terms of generating its error messages. But at text semicolon, it says at text semicolon, unexpected semicolon, expected star, or literal token, or a hex list, one or the other. So point being that when you say data, it's expecting you to specify data, which is literal token, or a hex, or a string of hex byte values, or star, meaning you choose what you want to say, what you want, let the tool choose what it wants the data to be. So it's maybe not really super great parsing error generation, but at least it's fair.
So another question from me. So this has been written, particularly for the TFM PSA specifications and the APIs that defines, which variations of them are expected at some point in the future to come to TFA. But if we wanted to reuse your tool in some other APIs that we have, how easy do you think it would be to refocus it?
Yeah, reasonable question. This is very much a PSA focused tool. When you really get down to it, that's the primary goal. So it's primarily targeted toward the PSA implementation. Now, of course, Mark has a fuzzer that's more general, any SMC call, but it has a very different emphasis. Again, it's a little less, as I understand it anyway, I'm not an expert on Mark's tool, but it's a little bit less oriented toward directed random testing. It has a little bit less, as I understand it, Mark, correct me if I'm mistaken, it has less prediction of expected results, and it's much more general in terms of other APIs. This is very much more focused toward PSA. Now, as I pointed out earlier on, though, it would be I would expect it to be very feasible to create plugins where you can, whereby you can tell it to run additional code that you're hoping will confuse the PSA implementation. But it is very much focused upon PSA in particular.
Okay.
Yeah, I would say that the whole idea, I think with Gary's, his is more PSA specific. I mean, mine's more SPC specific in that sense. And but I mean, you could easily apply my tool toward PSA calls without too much reworking. So I guess the general point is it's a little more generic, I guess, in my fuzzing tool than it would be for his.
Do you have checking of behavior to make sure that it produces expected results as you pass-fail results as expected?
Yeah, it's inbuilt with the results coming back from the SMC calls. We have checking occurring there at that level. Yes, so you can easily do the same thing with PSA calls from my fuzzer.
Okay, cool.
Okay.
So for example, just real quickly, for example, if there's if you're deleting an asset that never existed, for instance, would there be a means of detecting that?
Well, I would have to know the particulars of how the detection would take place, but for instance, for the SMC calls, you have error codes that are returned from the call itself, and you have system interrogation calls that you could potentially leverage to know whether behavior occurred as expected. So yes. I would have to know the particulars of what you're referencing here as far as an asset, but yeah, I think there's some possibility that some fuzzer could do the same thing. But we could take that offline and discuss it in more detail if that's something you'd like to do.
Okay. Okay, cool.
Okay, so our hour is up, and unfortunately I haven't really given any time for any other questions or anything, but I'm willing to stay around for it.
No, I have not given enough time.
I am happy to take anything critical on anybody's mind for a couple of minutes, but I appreciate folks will probably need to leave if they've got follow-on meetings. Is there anything critical from the mailing list that anybody had that they feel they really do need to talk about here? All right, I'm not hearing anything. So the next meeting that we have is in 2 weeks, and there where we're going to try to look at the SPM Hafnium technology, and so that one, as I said, it'll be that's what the current target is for the next meeting. As always, I'm happy to take any other subjects people want to talk about. I actually created a schedule page where we list in these items now. I think I put that in the mailing list, the agenda pointers to that. So if anybody wants to see what possibly is coming in the future, or wants to think about presenting something themselves, because it's I'm more than happy for anybody else to have an interesting subject for us to talk about. But if not, if there's nothing else anybody wants to say, we're 2 minutes over now, so I will let everybody go. So thank you again, Gary and Mark, for your contributions today, and speak to folks on the mailing list or at the next Tech Forum.
All right.
Okay, thank you.
Thank you. Thanks.